Hi, my name is Patrick, and this is Prep Mindful, your daily video practice in mindful test prep. Coming at you today with an ACT math question. This is question 56 on the math section of ACT 74H. Right there, you could pause it, pause the video, read this friggin' essay of a problem, and take a crack at it yourself. Then unpause the video and watch the explanation. Could be good. Because we're getting in there. It reads, at Wafer Technologies, fine, I'll say wafer. At Wafer Technologies, identification codes each consist of the following sequence. 1 digit, 4 letters, 1 digit. For any one code, the digits, 0 through 9, may be the same, but the letters, each from the English alphabet, must all be different. Which of the following expressions gives the probability that a randomly selected identification code contains the word math, spelled correctly? What are the odds? Well, that's actually exactly what they're asking. What are the odds? All probability fits into the format of desired outcomes over total outcomes. Why don't we start with how many different codes could one make? Well, there are 6 slots. Digit, 4 letters, digit. How many different digits could go into this first slot? 10, right? And how many in the last slot? 10, because it's okay if we have repeats. How about this first letter? How many different options do we have? 26, right? If that's news to you, maybe start with an earlier video. So we have 26 in the first slot, but we can't use that letter again, so the next slot is 25. And we can't use that letter again, so it goes down to 24 and 23. And what we would do with all these numbers to figure out how many different codes there could be would be multiply them, like you do with all permutations. So 10 times 26, 25, 24, 23 times 10 is how many different permutations are possible. Well, so that would be the denominator in our desired over total. Let's pause here and see if we can find the answer. F says 10 squared over 10 squared times 26 to the fourth. No, the numbers have to go down because it's 26 times 25, so it's not F. Let's look at G. Denominator is 10 squared. Oh, well, those are the 10s on each side. Times 26, 25, 24, 23. All right, we'll keep it around. Let's look at H. 10 squared over 10 times 9. No, they're both 10s. It's okay if we repeat digits, so it's not H. And we go to J. 10 squared times 26 to the fourth. Nope, they forgot about how you can't repeat the letter, so it's not J. And then K. 10 times 26, 25, 24, 23. What the heck? What happened to the last 10? So it's looking like it has to be G. But let's take a moment to think about the numerator. How many different combinations would there be that contained the word math? Well, there's no rules about the digit, so that first slot will be 10. There's only one M, so second slot is 1. There's one A, third slot is A. There's one T, fourth slot is 1. And there's one H, fifth slot is 1 as well. Because we only had one option for those 4 middle slots. And then the last one, there are 10 digits. So if we multiply all these together, there are 10 squared different codes that would include the word math. Ugh, what do you know? That's exactly the numerator in choice G. Amazing. Always helpful in probability questions to start out with desired over total and try to clarify what those two things would mean. In this case, the total was how many different codes are possible. And once we articulated that clearly, we could actually choose the answer choice without worrying about the word math at all. Pretty cool. If you enjoyed this video and found it helpful, why not subscribe to our channel? Or go out and start your own wafer technology. If you have any questions about this problem or any others, feel free to hit me up in the comments below, or you can email me at prepmindful@gmail.com. In the meantime, my name is Patrick, and this has been Prep Mindful.